let's write this down. First thing I want to do is, let's look at your calculator. You have your data for the width of this room. The width of this room is actually 40 feet. What was your median? 40 feet. That's the exact same as this morning. Period 1 had the exact. So your medians were right on, which I think is kind of interesting. Okay. All right, let's look at this. Help me find the mean. So go back, because I don't know the mean. Mean is the x bar on your calculator. So stat, edit, or calculate one variable stats, x bar, very top thing. 40.09? 40.1? Let's go to the tenths, so it makes it a little bit easier to do. Okay? What we are getting into is transforming data. So in your notes, I would put 2.1, transforming data. And let me give you a quick glance. Y equals bx plus a. We're used to mx plus b, right? They use bx plus a. It doesn't really matter. What is your slope? What is your slope? It's always what's attached to the x. In this case, you're right, b. But it's whatever is attached to the x. So who cares what the letter is? M, B, A. Doesn't matter. It's whatever is attached to the x. Here's some notes real quick. And this is something that when we teach you this is from Algebra 1, right? Sometimes we forget, we get so ingrained as teachers that it's y equals slope, y equals mx plus b. And we go, all right, well, when you graph it, here's your starting point. And then you go up, over, and there's my slope. And we get so ingrained in teaching that we forget to tell you what the point of this equation is. You use it all the time. How many people have a job? Do you get paid at that job?
Yeah.
Oh, dumb question maybe. You have a rate of change. You are using a slope every time you go get paid, or your company is. Or how many of you have sat there and gone, see, I worked 30 hours times $8, and then you do the math times minus a little taxes. How much is my check going to be? Right? We've probably all done that. You're doing slope. You just don't, I'm going to do the slope equation right now. Probably not the way you're thinking about it. This is your start point, the A, or the y-intercept. The B, or the slope, is your rate of change. And I think it's important to understand that as we go through this. Your rate of change. What's your rate of change for working at a job? Your hourly rate, wage, right? I made $8 an hour, so there's my equation. 8 times H plus A. Who would have a plus A? Anybody, a waiter or waitress? You get tips? Okay, so you might get tips, let's just say. So you get $8 an hour or whatever it is, and then at the end of the night go plus, I got $39 in tips. That's the plus part of it. So automatically I got 39, plus later on I'll get the rest of my check, kind of a thing. That's what slope-intercept form is about. That's why it's so important. People use it all the time. We just kind of forget about it. So here's the deal. We went through and we found all, we'll continue to do it, but we're going to work with all this in terms of feet. So our mean was 40.1 feet for our class, right? How about the median was 40, right? I'm back to the width of the room. 40 feet. How about our quartile 1?
37.5.
37.5. Quartile 3?
43.
43. And let's just say the 80th percentile, I'm making up some number, but let's just say the 80th percentile I told you was 48. Okay? We'll come back. How about the standard deviation? Let's use, let's just use the sigma since most of you used it. 3.94. Is that what it was? So we'll say 3.9. IQR, 43 minus 37.5. We're talking 6.5. I did my math right?
5.5.
5.5. Thank you. 5.5. And our range, what was the min and max?
The min was 30, the max is 47, so
17. 17. Second on that? Thank you. Awesome. So we go through all this work and I go, oh, sorry. I need that in inches. Not feet. I want it in inches. So we've got to transform that data. What can I do to transform the data? Think about slope-intercept form. I could either have you each go through, multiply by 12, tell me what you got. Multiply by 12, tell me what you got. Multiply by 12, tell me what you got. Oh my gosh, please, isn't there a faster way? Yes, that's what I'm going to teach you today. So we want to transform the data from dollars to cents. Degrees Fahrenheit to degrees Celsius is a very popular one that they like to use. In this case, feet to inches. Suggestions. How can we convert this? If I have something in feet, and I want to know how many inches it is. Just multiply by 12. Right? If I was going the other way, I'd multiply by, if I was in inches and I want to convert it to feet, I would multiply by 1/12, or divide by 12. It's the same thing. So here's my equation. My new, so y of new is equal to 12 times the old plus a. And in this case, what I want to do is I want to not only know the width of this room, but I want to add the brick walls as well. And each brick wall has 1 foot bricks, so they're the thick bricks. So that's a foot, and then that's a foot. So I'm really saying from the outside of that wall to the outside of that wall, how much square footage is my blueprint, or my footprint taking of this, just this room? So what do I have to add?
2.
Plus 2?
24.
Plus 24, right? It's 2 feet, but 2 times 12 is, so I need to add 24 inches. And that'll help me convert. Once I have the equation, then I can go through all this data. I just plug right in. Okay, so y of mean, and I'll put a little n there, meaning the new mean, is equal to 12 times 40.1 plus 24. And what do you get?
505.2.
Thank you. 505.2. 505.2 inches is our new mean. Okay, what about the median? Y of the median new is equal to 12 times 40 plus 24. We're talking 504. 504 feet. It's a lot easier to do that than have everybody recalculate. And can you imagine if you had thousands of pieces of data? It would take a while. Of course, you can use Excel, and I'll show you how to do something similar to it today, but on your calculator. Okay, so let's do Q1. That is new. 12 times 37.5 plus 24. Anybody got it?
475 or 474.
Even?
Yeah.
474? 474 is our quartile 1. How about our quartile 3? New. 12 times 43 plus the 24.
540.
540?
540.
Fantastic. And then let's say something I want to know about the 80th percentile. Well, whatever the percentile is, new, is equal to 12 times whatever the number was plus 24. 600? Even? Fantastic. Thank you guys. Really appreciate you being quick about that. When we talk about measures of center, that's your mean, median, average, your Q1s, that gets just plugged into the equation. But when we talk about spread, we ignore the plus part of it. Okay? You ignore this plus A, get rid of that. Don't do it. Because here's what happens. We have it in feet, and all of a sudden I want it in inches. All that does is shift this down the scale and puts it in inches. Will it expand that picture? No. So this standard deviation shouldn't get spread out. So I have to ignore the 24. Just that whole graph gets shifted. Okay? So for our standard deviation, y of standard deviation new is equal to the absolute value, which is almost always what it is anyways, making a positive number. 12. Absolute value of 12 times the old of 3.9. The plus A, drop. Don't even write it. What do you get? 46.8. Okay, there's our new standard deviation. How about our new IQR? absolute value of our slope, which is just positive in this case, times 5.5.
66.
Even? You guys are good. I love it. And our range is just the absolute value of 12, or just write 12 times, what was our range?
17.
17 was our range? Oh, yeah, 17, which
204.
204 inches. Right? So now we have all that information in inches. So for transforming data, biggest part of today's lesson, there's a couple other things, but the biggest part for today's lesson is this part. When I go to transform something, I plug it into an equation. The plus A, I continue it on until I get to measures of spread, which is IQR, our range, how wide are we, our interquartile range, which is a little bit of a spread, and our standard deviation, which is how wide till we get to one standard deviation kind of a thing. These three, you drop the plus A. Now what happens if I just said you make $8 an hour and I want it in money, in change? You multiply by 100, right? 100 times X. Is there any plus to that? No, it would be just I make $8 an hour, so there's no plus to it. Then this becomes plus 0, and it doesn't affect anything, because you can almost ignore it then, right? So don't let that throw you off. There is such a thing as this being plus 0. There just isn't any extra stuff to it. And don't let that throw you off. Okay? All right. Let me clear this page. And let's go back to our calculators. Pull out your calculators again. And just follow along. We're going to graph our data. So here's second y equals, plots off. I'm going to turn it on. I'm going to do a scatter plot. And I'm going to look at list 1. Yours is probably already sitting there at list 1. And I'm going to do graph. I don't see anything. Don't panic. Do zoom 9. In other words, zoom in on my statistics. So everybody's graph should look like this. Good? Does yours match mine? It doesn't. Is it? I wonder. You might have typed a number in wrong. Or let's see. List 1. So you should be good. Oh. Let's do. I just went. Reset. Yep. Oh, make this a histogram now. So I'll make it a histogram now. I'll get rid of that one. Yep. As you turn this, it's my history. Okay, so if I look at this real quick and I want to interpret it and do kind of a SOX, how would you describe the shape?
Approximately normal.
Approximately normal, right? Not exactly normal, but approximately normal. Actually, that's not bad. I didn't do anything with this except ask you what the width was. Almost everything in life is approximately normal. Shoe size, clothes size, light bulb, length of a projector before it dies, the length of desks and how long they survive, your car, the tires on your car. Everything is basically a bell curve because you have some on the low end, you have some on the high end, but a lot of people are in the middle. And that's what a bell curve is. I didn't have anything to do with this, and look at how accurate we kind of became. Okay? Centered around what? You remember?
40.
40. Now, if you hit trace, it'll go through and it'll put a little X here, and then it says down here max and min. The min is this point, the max is this point. And then you hit trace and it'll go to here. And then it'll go min and then the max. And then it'll continue to do that. It kind of gives you the width of the bin, what we call the bin. Okay, just as an FYI. Yep, Molly.
How did you find that movie?
How did I find it?
Yeah.
In my head?
Yeah.
Because I am that smart. I mean, let's just state it. No. because of the median. I knew the median was
Oh,
40
yeah,
from
okay.
before,
Okay.
right?
So you just.
I would have known. I would have looked it up in the
Yeah.
calculator. Otherwise, you can hit trace, but yeah, you're right. You get the little max and min. You don't exactly know. So that's why you'd have to look it up specifically. Okay, so that was in feet, right? I go, well, but I want to convert it. So let's go to stat, edit, go to list 2, clear it out. Follow along with me on this one, because this is where some people will be like, oh, cool. It'll help. I want to convert this. Instead of going back and multiplying each of these, it's plus 24, right? But 12 times list 1 plus the 24. What will this do? It'll take 12, multiply by this number, add 24, and put it there. 12 times this number, add 24, put it there. 12 times this number, add 24, put it there. If I just hit enter, it does it real quick for me. So I don't have to sit there and type them all in. I can just do it quick. Yep.
I did list one.
So stat, edit, you highlight highlight L2, 12 times second number 1. See the L1 right above it? Plus the 24, and then when you hit enter, it fills it all in. Yep. Nate?
Yeah, mine did you go like scroll up like?
What do you have for?
Yeah.
Oh, yeah, that's stat. Edit. So highlight L2.
There we go.
You gotta highlight the L2. That's what. If you put it here, because some people come back down to clear it out, and then they're sitting in this cell, you have to tell it, do it for the whole list and fill it in. Otherwise, it does it just for that cell, and then it comes back and says, I'm not sure what you're asking for, and gives you the error. Did that fix it for everybody? Good. All right. See what I mean? One person has a question, and then all of a sudden 5 others go, yeah, me too. And if nobody asked that question, you would all be stuck. And it was a very good point. So keep that in mind as we go through the year. So let's graph it. So I go to second y equals. Plots on. Should the graph change? Let's find out. I go down. It's still a histogram. Go down to XList, and let's change that to L2. This time I want to graph L2. Hit graph. I don't see it because it got shifted, right? So let's go and do zoom 9. My friend, zoom 9. Boom. There it is. Is that in inches or feet?
Inches.
That one's in inches. Does the graph look any different?
No.
It's the exact same thing. So in terms of our mean, median, mode, that kind of stuff, that doesn't change in terms of our transformation. It just gets shifted. So that plus 24 was important. However, did the spread get changed? No, this didn't get wider. It just got shifted. So then that whole plus 24 gets ignored. Make sense? Okay, let's talk about density curve real quick. I don't know if you need any notes on this, just pay attention. In fact, don't write notes on this. This is good common sense. Density curve, this is in your book, but it's, I got a green box. A density curve is a curve that is always on or above the horizontal axis and has an area exactly 1 underneath it. All right, let's put this in English. Is always on or above the horizontal axis, meaning this comes down but never actually hits that graph. It's kind of like an asymptote, right, where it never actually hits the hyperbola, kind of a deal. Because there's always got to be room for that one person that's super short, or that one person that's got really huge feet, size 18. Well, what if there's somebody that's an 18 and a half and we just haven't found that person yet, right? So keep that in mind. That's why it never actually, we got to leave room for anything on the far ends. The area under the curve is 1. People in calc, you're working with, or will be working with integrals, right? And the integrals are the area under the curve. So if I draw a line right down the middle, what's the area in red? If I cut it right down the middle? 0.5. So this is 0.5, which is 50% of my data. But in terms of my bell curve, it's 0.5. What if what's the area above that red line? Up here. The area is 0.5. What if I'm way out here, and I want the area here? I don't know, maybe that's 0.9. 90% of the data, or 0.9 out of 100. Just moving the decimal over twice, right? So the area under the curve also represents the percents. But that is 1 or less. In other words, 100% or less. Density curve describes the overall pattern of a distribution. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations. Does it always have to be a curve? What if it looks like this? Is that a density curve? Sure. What's the area under that? 1. What if it looks like this? It's what we call a uniform distribution. You end up getting bar graphs that are actually all the exact same. Is it a curve? No, but does it have density to it? Yes. This density still has an area of 1. So don't let that throw you off. Your density is still 1 in that scenario. It's just not curved like we would think it would be. Okay? So sometimes you'll throw a question like that at you. And then let's look at this. This is just a quick, remember how the mean gets sucked out towards the tail? I wanted to show you a picture of the mean versus the median. Let's say I have a skewed right graph and I cut it out of wood. If I cut it out of wood and I draw a line right down the middle, that's the median. Median of a density curve is the equal area points, the point that divides the area in half. So in other words, this area and this area are the exact same in terms of area. However, the mean, why does that get sucked out? The mean is basically your balancing point. So if anybody's in Wood's class and would be willing to cut this out, I'd love it because I've just never had it done. Cut out a piece of wood that looks like a skewed right graph. Let's just pretend this is it. If I have it sitting here and I try to balance it, it's going to fall, right? So I move it down here, it's going to fall this way. If I move it to the center, can I try and balance it on my pencil? Yeah, that balancing point is called our mean. Right? And that's why it gets sucked out because of physics. The physics part of it, if it was a piece of wood, says that this is going to be, it's drawn out, so the force of it's going to be changing a little bit, right? I have to throw that science stuff in here. But I thought I'd just show you a little quick picture on it. Okay, so transformation is the big thing for today. It's that y equals mx plus b, or bx plus a. When do you drop the plus a? When you're dealing with the spread, standard deviation, IQR, and range. And then we got into a density curve, and that's about it for today's lesson.